In this video, I will explain you about reflecting type telescope. So far we have learned about refraction type telescope, where we have seen that we have used glass type lens, and with that glass type lens we have seen chromatic aberration happening and spherical aberration happening, and the whole telescope is difficult to handle. Now Newton has introduced reflecting type telescope, where he has used a parabolic reflector. Now the light is coming from source, from the star, which we need to understand. These light rays are coming from star, and to create an image we need them to intersect at one point. And Newton has seen that with a parabolic reflector he can focus all these incident rays to one point, and at this point, if we are keeping an eyepiece, we would be able to see the clearer image of the star using this setup. So we have a parabolic reflector, and here we have kept our eyepiece, and seeing from eyepiece we can get the image exactly in the way we have done it for glass type telescope. And this doesn't have chromatic aberration because there are no refraction occurring. This doesn't have spherical aberration, and this is not difficult to handle because this is simply a parabolic reflector. Okay, so this is a reflector, and this reflector carries very less weight because simply a parabolic shape it is. But the problem here is, with the Newtonian telescope, a person to see the object, he have to go this much height above and have to see from here. He should have a setup here to see this image at the focus, right? Because these are intersecting at one point, and at this point the image is formed. To observe the image, this person have to be here and he has to watch this, which is practically difficult to do, but this can be done. He was able to introduce the concept of reflecting type telescope, but the actual practical telescope is given by Cassegrain, where he has done one change. So this is our parabolic reflector. Now the light rays are being focused at one point, and Newton has kept his eyepiece at this location, right? Now what Cassegrain has done is he has kept one concave reflecting surface here. Now what will happen at the reflecting surface after reflection being occurred there? This is just a mirror. After the reflection, that would go here and will try to focus at one point. So Cassegrain has made a hole here, and he brought this ray to one point where they intersect and create the image. Now from star the light rays are coming, and after reflecting at this surface they will go to one point, but these rays have met a mirror, so they will again reflect from this mirror and will have an image formed at this position. Now Cassegrain has kept the eyepiece here. From here, if you watch, we can get the same image. Now this is practically more feasible as compared to this. This can be rotated, this can be tilted to any angle, so that without any interruption to the observer, the images can be seen. So this is simply reflecting type telescope. So in the telescope, the light rays from the star are brought to one point to get a bigger image, and even this will have the same magnification. Okay, thank you.